Good afternoon, class. We are looking at Module 1, Chapter 3, Practice Test, Describing, Exploring, and Comparing Data. So we are given the following data. That is the number of hours that a few employees at the GM factory worked last week, 17, 38, 27, so on and so forth. And we want to find the mean. So what I like to do is to rank the data, although it is extremely important to know we don't have to rank the data if we are calculating the mean only. So we don't need to rank data for some calculations such as finding the mean. However, it's a good practice to do so for those calculations that need rank data. You'll see them in a moment that we need them otherwise. And so as far as the formula is concerned, and that is important that you show your work so your reader can understand what you're doing. Mean is defined as the sum of all entries divided by the size. So X bar is a summation of X over N. This refers to a few employees, and therefore this is a sample. We use X bar. This is the summation sign. This is a sigma, a Greek letter that represents summing. That means we are going to add all of these numbers. And then we're going to divide by however many we have. We have 18 pieces. And it's a good practice to go with a lot of decimals. And normally we go one more decimal than that, but you always truncate it at the last step. You don't round any number mid-step because you're going to miscalculate everything. Find the mode. There is no mode. Mode is defined as a piece of data with the highest frequency of occurrence. Nothing repeats. Since nothing repeats, there is no mode. The median refers to the middle of the ranked data. And that's what I mean. We don't have to rank it for the mean, but we do have to rank it for other calculations. So right in the middle, there are 18 pieces. So it's right here between these two, the 9th and the 10th one. So right here, we add up these two and divide by 2. Find the mid-range. The mid-range is defined as the value midway between the max and mean, which means you're going to add up the minimum value and the maximum value and divide by 2. And again, you see why it's important to rank the data. So we are going to add up these two numbers and divide by 2. Mid-range for this one is 28. The next one is asking for the range. Range by definition is the maximum value minus the minimum value by definition, and therefore it is 42 minus 14. The only thing I want you to notice, it happened by chance that the two values are equal. R and MR are not equal in general. In this case, it happened by chance. It won't happen in general. I can't emphasize this enough. It just happened here. For some reason, the calculation ended up giving us the same answer. We're going to move on. The next part of the question is asking for the variance and standard deviation. I want to go over that part. Generally speaking, we use calculators to do the job. I want to show you how it's done because it's important to know how the calculator does that and the formula. So we're going to go over that. It is important to pay attention to the fact that this refers to a few employees. Therefore, it is referring to a sample where sample variance is s squared equals summation of x minus x bar quantity squared over n minus 1. Or you may use the second formula for the sake of calculation, n summation of x squared minus summation of x quantity squared over n times n minus 1. So I want to show you how the calculation takes place. So s squared, it's easy. We're going to use both. I'm going to, again, illustrate that. If we want to use this equation, it is important to understand the meaning of summation of x squared. That means add up x squared. So the first one is 14, square it, plus. The second one is 16, square it, plus. The next one is 17, square it. That's what it means. So n, and we know it to be 18, we multiplied by that, minus summation of x quantity squared. That means first add them up and then square it. So take a look at this formula and how we put them together. N is 18. Summation of x squared means square them individually and add them up. Minus summation of x quantity squared, add them up first and then square them over n times n minus 1. This will give you the answer, which is extremely close to number 75. If we were to use this one, how do we do that? Summation of x minus x bar quantity squared divided by n minus 1. I wrote x bar from the previous page. And again, this is where you got to be very careful. You don't want to truncate this and round this. You want to keep it as such because you want your s squared to be as close as possible to the real number. Therefore, summation of x minus x bar means 14 minus the x bar 26.9444 squared plus 16 minus this number squared all the way to the end plus 42 minus this number and squared over n minus 1, 18 minus 1. So if we use this formula, the first number minus the mean quantity squared all the way to the last number minus the mean quantity squared, add them up over n minus 1, and it gives you the same answer, 75. That is called the variance. Normally, we are interested in standard deviation, and that would be the square root of this number. We want to find the IQR, the inner quartile range. What is IQR? The IQR describes the middle 50% of values when ordered from lowest to highest, again, the rank data. And by definition is Q sub 3 minus Q sub 1. And Q sub 2 represents the median. We've already seen that. So we added up these two and divided by 2, it was 26. Now, one easy way to calculate the Q sub 1, and there are different methodologies, is to look at the bottom half, and the median of the bottom half is Q sub 1. Look at the top half, the median of the top half is Q sub 3. So again, This is the number here between 25 and 27. Then we look at the bottom half and the median of the bottom half. There are 9 pieces of data. The 5th one, which makes it number 20, and then the top half, the median makes it number 14th. So Q sub 1 is the 5th piece of data, which is 20. 20. Here's the median between the two divided by 2. And 14th piece of data, 34. Now, what is IQR? Q sub 3 minus Q sub 1. And that difference is 14. Now, as I mentioned, we normally do this with a calculator. I put the numbers that we calculated by hand, but you do have a TI calculator command I gave you. You don't have to use that. You can use other means, other calculators that I've given you online. But here's the commands that will help you get there. So, for example, you click on stat, clear list. For example, if you want to clear the L sub 1, okay. And then you edit and type in your data in one of those. For example, L sub 1 is the list. You put in the numbers. Then again, stat, calc, select 1 for one variable, type L1, and then enter. This way you can see the result. So if you go to stat and calc and one variable stats, as if you're using a calculator, I'm showing you step-by-step process. And when you get to calculate, you press enter. It will show you the following. And you see the arrow. You enter. So you see this and you see this. Now, what does it mean? Take a look. It gives you the X bar. We've done it by hand. It gives you S, and I want you to pay attention. We have sigma sub X and S sub X. This is if it's dealing with a population. And the calculator doesn't know it's a population or sample. You know it's a sample, and most of the time we deal with a sample. Therefore, the answer is 8.66. That's what we have here. We wanted Q sub 1, Q sub 2, and Q sub 3. Q sub 1, Q sub 2 is the median, and Q sub 3. By the way, it also gives us the following numbers. The minimum value, if you recall, it was 14, and the maximum was 42. Minimum value, maximum value. Of course, the more the number of the data, the better it is to use technology to get there. But you need to understand the concept. So nobody expects you to do this by hand, but you need to understand what that means. IQ scores have a mean of 100 and a standard deviation of 15. We want to find the coefficient of variance. Anytime you deal with stats, most questions are word problems. So the very first thing you do, you write the given symbolically. the mean is 100, and we are going to use mu, and the standard deviation is 15, we are going to use sigma because this refers to the whole population. We don't have a specific sample size. Mu is 100, sigma is 15. Now, what is coefficient of variance? The coefficient of variance, or CV for short, describes the standard deviation relative to the mean, and it's used to compare standard deviations when the units are different. So simply put, divide 15 by 100, and all you have to do, change it to a percentage, which becomes 15%. If you said the answer is 0.15, you are not wrong. But normally, we represent it as a percentage. Remember, 100% means 1. Use the range rule of thumb to estimate the minimum and maximum usual IQ scores. What is the range rule of thumb? Mu plus minus 2 sigma, or x bar plus minus 2s. In other words, you start from the mean, mu or x bar, and you go 2 times the standard deviation. You go 2 times the standard deviation to the right. You go 2 times the standard deviation to the left, and this is known as range rule of thumb. The reason being because when we use normal distribution or empirical rule, which is bell-shaped, when we go 2 standard deviation on each side, it will cover about 95% of the data, and that is good enough for most everybody. That's why it's called the range rule of thumb. So with that being the case, mu plus minus 2 sigma, in this case, mu is 100, plus minus 2 times 15. This is 30, so 100 minus 30 is 70, 100 plus 30 is 130. So that's known as the range rule of thumb. Using Chebyshev's theorem, find what is the least percentage of those who will have an IQ score of 70 to 130. Using empirical rule, we want to do exactly the same thing. So the best idea about that is to understand what's Chebyshev's theorem. The proportion of values from any data set that fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is a number greater than 1, and it's not necessarily an integer or whole number 0, 1, 2, 3, and so forth. So we need to find k, the number of standard deviations, and we already know that when we go through standard deviations, we go from 70 to 130. In other words, k, we've already known from part B to be 2. However, I want to show you in case you don't know it and you need to calculate it. So from part B, we went from 70 to 130, and we're going to do the same thing here. So from here, we know it's 2. But what if we didn't? Here's how you calculate it. There are simple ways. One is, if you put the mu right in the middle, which is 100, and then on this side, you're going to go to number 130. So there are 2 ways. I'm going to show you both ways. On this side, you're going to go to 70. And you look at the difference between the two. Again, we've already used the previous part. We know that. But if it wasn't given, this distance is 30. So is this distance. And each one you divide by sigma. So when I divide 30 by sigma, which is 30 divided by 15, that means 2. What it means is the mere value of 30 may not mean anything, but how many standard deviations would number 30 stand for? Number 30 is 2 times sigma, so this distance is 2 standard deviations away. So we go by that methodology to know exactly what number 30 means. Number 30 means 2 standard deviations. This is one way to do that. The second method, you could say from 70 to 130, the difference is 60. And now this has to be divided by sigma, which is 15, and that means 4. So I want to make sure everybody understands what that means. From 70 to 130, the difference of 60 represents 4 times the standard deviation. So if mu is right in between, each side is half of this 4 sigma, which means 2 sigma. Again, I just wanted to be absolutely positive you have no problem with the calculation. We've already done that from the previous part. So let's plug in. 1 minus 1 over 2 squared. 2 squared is 4. 1 over 4 is 1/4. 1 minus that is 3/4. Therefore, at least 75% or 3/4, because 3/4 is the same as 75%, have an IQ score of 70 to 130. As far as the empirical rule is concerned, first let's look at this graph. When we start from the mean and we go only 1 standard deviation on each side, it covers about 68% of the data, if it's normal distribution or bell curve or empirical. If we start from the mean and we go 2 standard deviations on each side, take a look. It covers about 95% of the data. But if we start from the mean and we go 3 standard deviation on each side, then it covers almost everything, 99.7% of the data. We know from 70 to 130 corresponds to 2 standard deviations, 2 standard deviations. Therefore, it covers 95% of the data. All right, here's the data given. Number 1, we want to rank the data from smallest to largest. Then we want to come up with the box and whisker plot. So we're going to write the numbers in order. The next thing is we notice if we cut it in half, right here we have the median or Q sub 2. There are 14 pieces of data. 1, 2, 3, 4, 5, 6, 7, and we have 7 here. 8, 9, 10, 11, 12, 13, 14. There are different ways to calculate those. The median is very straightforward. You add these two and divide by 2. If you happen to have an even number, such as 40. If it's odd, there is one number in the middle, and that is your median. So again, when the number is an even number, such as 14, there is no number in between. That's why you want to add these two and divide by 2. So there are different methodologies of finding those, and we're going to discuss them, okay, for Q1 and Q3. So these two, add them up, divide by 2, that is Q sub 2 or median. That's not a big deal. But what about Q sub 1 and Q sub 3? One is to go with the location, and Q sub 1 separates the bottom 25% from the top 75%. So you can see that the bottom 25% or 0.25 times the n, the locator, the number of data can give us the location. That's what this means. So we have Q sub 1, 25% or 0.25. That's what it is, K over 100, 25%. If we multiply by 14, we get 3.5. We must round it up, and that gives you the fourth piece of data. And that is number 7. For Q sub 3, the bottom 75% are separated from the top 25%, and this is a 0.75 or 75 over 100 times what number? 14. Why 14? There are 14 pieces of data. The answer is 10.5. Rounded up is 11. So we want the 11th number. And this is the 11th number, because this is 7, 8, 9, 10, 11. And therefore Q sub 3 is number 19. When we want to come up with the box and whisker plot, basically we have a box and there are two whiskers. We have to have the following: the minimum value here, the maximum value here, and then in between we put Q sub 1, Q sub 2, and Q sub 3. Q sub 1, Q sub 2, and Q sub 3, they would be put at top of sort of a box. So take a look at how we do that. So we need the minimum, we need the maximum, and there is a line that connects them. We have Q sub 1, Q sub 2 or median, Q sub 3. This is the box, and we put a line here, and it's called box and whisker plot, because this is your box, which contains Q sub 1, Q sub 2 or median, and Q sub 3. Whiskers, here's the minimum value, here's the maximum value. We're going to continue with the same question, and we want to find if there is any outlier. Basic definition of outlier: something that it's out there, that it's way off. And how do we find that mathematically? We have formulas. Sometimes it's easy to figure out what's an outlier, but can you prove it's an outlier? We are going to do it with mathematical formulas. And so first and foremost, here's the definition. The values for Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 times IQR are the fences that mark off the reasonable values from the outlier values. Outliers lie outside these fences. So any number less than this any number larger than that is considered an outlier by definition, because we want to be more specific as to what will constitute that. So first and foremost, we're going to calculate the IQR, which is Q sub 3 minus Q sub 1, and we got this from the previous page. So IQR is Q sub 3 minus Q sub 1, which is 19 minus 7, which is 12. We're going to multiply that by 1.5. 12 times 1.5 becomes 18. So what is considered an outlier? Q sub 1 minus 1.5 IQR. So 7 minus this number. And Q sub 3, that means 19 plus this number. So the data is considered an outlier if its value is less than this. So 7 minus 18 minus 11, anything less than that, or if it's larger than this. Now, Q sub 3 is 19. Let's add this 18. Anything beyond these two numbers, less than negative 11 and larger than 37, are considered to be outliers. Now, we also have a definition of an extreme outlier if we use 3 times IQR instead of 1.5. Normally we don't use that, but sometimes they use that, in which case if the IQR is 12 times 3 becomes 36. So first of all, 50 is an outlier. Remember, we have them in order. And the reason why is because 50 is larger than 37. 50 is larger than 37. The question was, do we have an outlier? Yes, absolutely. But also the extreme outlier, Q sub 1 minus 3 times IQR, so 7 minus 36, or Q sub 3, 19 plus 36. So in case you come across it somewhere, that's known as extreme outlier. We are interested in a basic outlier, and 37, we compare the two numbers. We're going to continue on that thoughts, and we want to see if we are dealing with a symmetric or skewed data. And so in order to answer that, you want to be very careful. Number one, make sure the drawing is to scale. So when you do the drawing, you have a number line, make sure this scale is followed so it can show you whether it's skewed or not. Number two, skewed data show an uneven box plot, in which case the median cuts the box into two unequal pieces. So the median shows two unequal pieces. Longer part on the right or above the median indicates data is skewed to the right or positive skew. In this case, the mean is larger than the median. Longer part on the left side or below the median indicates data is skewed to the left or negative skew, in which case the mean must be less than the median. Number three, sometimes the box may look even or uneven, and even skewed to one side. However, the whiskers, tails on each side of the box may indicate otherwise. Therefore, pay attention to both of them. So take a look at the way I'm going to approach this. I look at Q sub 2 and I draw lines. On the left side, this is clearly shorter than this one. It's longer from here on, and therefore I'm going to say it is skewed to the right. The mean is larger than the median. Here's another example. We want to come up with the box and whisker plot. Again, just quickly, in case anybody had a problem with that, it will look something like this, where this is the mean, this is the max, and this is Q1, this is Q3, and somewhere in between is Q2. That's the general idea, the 5-number summary. That's what we are looking for. So we want to make sure that data is in order from smallest to largest. It is. So we cut them in half, and it makes it very easy to find Q sub 2 or the median. Add these two numbers, divide by 2, and it's the median. Now, there are different ways of calculating Q sub 1 and Q sub 3, and I'm going to go over an easier way. This splits the list into 2 halves. If you look at the bottom half, we have those 4 numbers. And if you look at the top half, we have those 4 numbers. Since the halves of the data set each contain an even number of values, the submedian will be the average of the middle 2 values. So here's the middle of the bottom half, or the median of the bottom half, 79 plus 80 divided by 2. And here's the middle of the top half, or the median of the top half, is 87 plus 94 divided by 2. This is the fastest and easiest way to get to Q sub 1 and Q sub 3. So the 5-number summary, we're going to write the minimum is 77, the maximum is 99, and Q sub 2, we have it, and write these two. So we have mean, Q sub 1, Q sub 2, Q sub 3, and the maximum. We want to write all of them. And now we put that into a 5-number summary, or whisker, box and whisker plot, looking like this. Again, it has to be to scale. So this is 77, 79.5, 86.5, 90.5, 99. So this is the minimum, Q sub 1, median, or Q sub 2, Q sub 3, and maximum. Now, I'm going to show you the IQR. It was an ask to come up with the outliers, but I want to quickly show you and remind you how we found the outliers. So Q sub 3 minus Q sub 1, since we have them, the difference of the two is 11. We're going to multiply this by 1.5 and subtract it from Q sub 1. So 79.5 minus 1.5 times 11 gives you 63. And we're going to multiply it by 1.5 and add it to Q sub 3, gives you 107. So a number less than 63 and larger than 107 would be considered an outlier. And in the case of an extreme outlier, we have to multiply by 3 IQR, subtracted from Q sub 1, and add it to Q sub 3. I just wanted to remind you of that. In any event, they didn't ask. And by the way, if you look at those numbers from 63 to 107, there is no outlier. In the meantime, if you look at the way I'm going to draw the line from Q sub 2 to the left and Q sub 2 to the right, it seems that it's almost the same. They are not identical, but they are almost the same. And therefore, the data is almost symmetric, normal, or bell-shaped. If you were to graph it, it would look like this. Median and mean are at the same place. That's the meaning of symmetry. What I want to add here is, what if? The situation that sometimes students ask. In this case, we had 8 pieces of data, and it was an even number. So what if n is odd? So let's say we have the same pieces, and I throw in another number, 103. And now I make it odd. So the middle piece, 87, there's only one number in the middle, 87. That is your median or Q sub. Now, the bottom half, including the median, is this, and the middle of the data is 80, that's Q sub 1. Normally, they will include the median in the case of odd size with the bottom half, as well as the top half, in which case, for the top half, the middle of the data would be 94 and Q sub 3 becomes 94. In some instances, they do not include that. So I mention it because there are many different ways of calculating this. You stick with the way that the text and your digital platform is asking you. If the mean of a set of data is 23 and 12.6 has a z-score of negative 1.3, then the standard deviation must be, well, what is given first and foremost when we read the question? This is mu. This is some x score, and this is the z-score. I'm going to give you the given, and I'm going to give you the formula for the z. You have access to the formula sheet. This is x minus mu over sigma. X minus mu over sigma. We want to find sigma, we want to find standard deviation. I hope you know that if you do the cross product and then solve for sigma, you can get that. I can quickly show you, but this is a basic elementary algebra question. If you do the cross product, z times sigma is 1 times x minus mu. And now if I divide both sides by z, I get to this formula. So that's very straightforward. Now we are going to plug in x 12.6 minus mu 23 over z negative 1.3, and we put it into a calculator, results in number 8, and that means D must be the answer. Find the z-score for each student and indicate which one is higher. We are looking at art major versus theater major, and because of that, we just don't look at their raw data, we will look at their z-score. So z-score uses x minus mu over sigma, or x minus x bar over s. So we calculate for each one. For example, for the art measure, x minus x bar, that means 46 minus 50. This is the mean, by the way. X bar is the mean, s is the standard deviation. We divide by 5. We get negative 4 over 5, or negative 0.8. We do the same thing for the theater measure. That means 70 minus 75 divided by 7. And that gives us negative 5 over 7, or negative 0.7143. First, I want to mention the meaning of negative z-score. If the z-score is 0, that means your score is the same as the mean. If you look at the numerator, it should tell you. If this becomes 0, that means the score that we are referring to is equal to the mean. If it's positive, the score is larger than the mean for the class or the data. If it's negative, that means is less than the mean for the class. So both of them are negative, both of them received grades less than the mean in the class. However, this is more negative than this one. This is worse than this one. So the theater measure has a higher score than the art measure. Again, both of them less than the value of the mean, but since this is less negative, it has a better score. If the 5-number summary for a set of data is given as 0, 3, 6, 7, and 16, then the mean of this set of data is. The answer is B. There is insufficient information to calculate the mean. Why is that? Because to calculate the mean, you need the following formula. X bar is summation of X over N. That means you need every piece of data to add up and then divide by size. And therefore, we can't calculate the mean because we don't have every piece of data. Which of the following is true? It has got to do with understanding the meaning of D and P and Q. So I want to go over that. The answer is B. D5 is P50 is Q sub 2. D is the decile. P is the percentile. Q is the quartile. So the answer is B. Let's look at their definitions quickly. Deciles, measures of location that divide the data into 10 equal parts. Percentiles, measures of location that divide the data into 100 equal parts. Quartile, measures of location that divide the data into 4 equal parts. And that's why D5, P50, and Q sub 2 are identical. A student received the following grades: an A in statistics, 4 credits, an F in physics, 2, 5 credits, a B in sociology, 3 credits, a B in literature, 2 credits, and a D in tennis, 1 credit. Assume A is 4 grade points, B is 3, C is 2, D is 1, and F is 0. And that's how your GPA is calculated, by the way. So what is the GPA for this student? GPA, grade point average. We use what's called the weighted mean. When different X data values are assigned different weights, W, we can compute a weighted mean. To find the weighted mean of a variable, multiply each value by its corresponding weight and divide the sum of the products by the sum of the weights. And to make sure we understand this, it's important to see that if you have just 2 courses and you receive A in one, which is really 4.0, and B in another, which is 3.0, does it mean now that your GPA is 3.5? Well, it depends on the weight. If the A course is a 5-unit course and a B course is a 2-unit course, it's not fair. And that's why we do the weighted average or the other way around. So what do? We have the grades A, F, B, B, D. The number of units for A was 4. This is the number of units, 4. For F was 5 units. For B was 3 units. Another B was 2 units. A D was 1. And how many points is A worth? 4 points. F, nothing. B, 3, and D, 1 point. So to calculate the weighted average, we use this formula, summation of Wx over summation of W. So that means you multiply this column by this column. 4 times 4, 5 times 0, 3 times 3, 2 times 3, 1 times 1, and you add them up. And you divide by the total number of weights or the total number of units, which is 4 plus 5 plus 3 plus 2 plus 1. So this column times this column divided by the sum of the weights, 32 over 15, 2.133. Normally we go with 2 decimals. I just wanted to show you more decimals just to be on the safe side. That's the answer for this case and this student, the GPA in that semester. And that's how your GPA is calculated. So you got to be familiar with this formula and how your GPA is calculated. You can calculate it always on your own. So we have this set of data, and we want to find the value that corresponds to the 75th percentile. And I want to show you how it's done. First and foremost, you have to rank the data. So you have to put them in order. Then we look at this locator L, if you will. N in this case is 1, 2, 3, 4, 5, 6, 7, 8. N represents the number of data. L is K over 100 times N. 75th percentile, that means this is 0.75, or this is 75 divided by 100. So this is 0.75 here. N is 8. So let's do the multiplication. And whenever they have a whole number, they, in this case is 6, they go with the next one, they add them up, they divide by 2. So in this case, they are going to go to the 6th one and 7th one, they add them up, divide by 2. 44 plus 56 divided by 2 is number 50. If we want the 30th percentile, again, look at this number. This means 0.3 or 30 divided by 100. So 0.3 or 30 divided by 100, we're going to multiply by 8 because N is 8, and we get 2.4. And we will always round up. This is what statisticians have decided. They will round up and it becomes the third number. So 1, 2, the third number, which is 15. Find the percentile corresponding to number 44. So you're going to locate number 44. And you're going to look at the number of values that are less than that, and you divide by N. So the number of values less than 44. So 1, 2, 3, 4, 5. There are 5 pieces of data less than 44. You divide it by 8. And whatever the answer is, in this case 0.625, you round it accordingly. So P63, if it was 0.621, you would say P62. That is the percentile corresponding to that. This is how statisticians do it. Number of values less than the specific number. Using range rule of thumb, estimate the standard deviation. As you recall, the range rule of thumb was that we would go 2 standard deviations on each side. And for normal distribution covers about 95% of the data, or empirical rule is called. So the whole range should be about 4 standard deviations. Therefore, if this is the case, mu plus minus 2 sigma or x bar plus minus 2s, so from the bottom to the top is a total of 4 standard deviations. So if you find the range, which is top minus the bottom, or high minus low, or max minus mean divided by 4, that would be roughly the standard deviation if we go by range rule of thumb. So this is in order. The maximum value is 72, the minimum is 10. So we subtract 10 from 72 and we divide by 4 according to this formula. So 72 minus 10 divided by 4 is 62 divided by 4 gives us 15.5. So range rule of thumb will give us S, which is roughly R divided by 4. In this case, 15.5. The following data representing numbers of keyboards assembled for a sample of 25 days in a company. One day was 45 pieces, one day was 52 pieces, another day was 48, so on and so forth. We want to construct a frequency distribution table with 4 classes. When we want to do that, this should be given to us just for the sake of the exam question or homework question, but on our own, we come up with a number of interests for us. We don't want to make it too many classes. So that should be given. So number one, let's rank the data. Number two, we have 4 classes. So we divide the range by the number of classes. It's important to know we are not dividing by 4. We are dividing by the number of classes which happen to be 4. So the width is calculated as a range, which is 56 minus 41, divided by 4. So this is the width. Now we have to round up just because we want to make it easy. Otherwise, it will be difficult to deal with it. So we round up and we happen to have a width equal to the same number. Don't mix them up. It just worked out to be the same. Now, if we want to come up with the frequency distribution table, the lower limit of the first class is the starting point. We have to start from somewhere. Normally, we use the first number as the lower limit of the first class, or a number smaller than that, which is convenient. However, it's important to know when we add the width and we go all the way to the last one, we must have all the numbers that we have here. Everything must be covered within our frequency distribution table. I hope everybody understands what I'm trying to say. So if you start with 41, for example, since the width is 4, if you go down, the next one, 41 and 4 is 45. The next one is 49, and so on and so forth. But what number goes here? Remember, here's the upper limit of the first class. And if you recall, the width was defined as upper limit minus lower limit plus 1 unit. And because of that, this number becomes 44. Or just fill up this, which means upper limit minus lower limit, which is 41, plus 1, and that must be the width, which is 4, and it gives you the 44. And now adding the width to that, if you go with this, so this is 44, and now adding the width, it gives you 48 here, and gives you 52 here. Then add the width of 4 gives you 53 here. Add the 4 here, gives you 56. And as you can see, using the lower limit of 41 and the width of 4, it covers all the way to 56, which means if you want to start with 40 is okay, but the width should be a little bit more than 4 for you to reach 56. That's why you want to be very careful when you write your classes. every number must be included. Therefore, look at the lower limit of the first class, upper limit of the last class, and so it will look something like this. Now, as far as the frequency is concerned, you really have to look at 41 to 44. Okay, so 41, 42, 43, 44, 44. So right here, that gives you number 5. So you want to write it in this fashion. From 41 to 44, we are here. And that means 5. From 45 to 48, we are here. And that means 1, 2, 3, 4, 5, 6, 7, 8. So I put number 8 here. From 49 to 52, 49 to 52, again, we counted as 8. And the last one. So that's how we come up with the frequency distribution table. So we made up the frequency distribution table. All right, so we're going to continue with the same question. Part B, use the data to find the mean. And we're going to use X bar is summation of X over N. So add them up, divide by those 25 days. There were 25 days, so add them up. 45, 52, all the way to the last number divided by 25. And that's the precise mean using all pieces of data. If you add up, divide by 25, you come up with 48.40. Now, what if we use the frequency distribution table to find the mean? In essence, it's estimating. It may not be exact. The point is, how do you find it? And when you find it, are they close enough? This is the process that the statisticians have used, and that is, if we have the frequency distribution table, that means normally we don't have every piece of data. If we do, that would be the best choice to calculate the X bar. So what if we don't? How do we calculate that? And we use the following format. X bar is the summation of F times X sub M over N. That means this N can be calculated easily, just add them up. So we have this one. But what is the numerator? This is F, the frequency. What is X sub M? X sub M. If you look at this class, for example, we know between 41 and 44, there are 5 of them. Could be that all of them are 41, all of them are 44, or none of them. Is it somewhere in between? We have no idea. So what they do, they use X sub M, which is the midpoint of each class to be on the safe side. So X sub M represents the midpoint of that class. For example, for this one, the lower limit is 41, the upper limit is 44. We add them up and divide by 2, and that gives us 85 divided by 2, which is 42.5. So lower limit plus upper limit divided by 2. As an example, the first one would be 41 plus 44 divided by 2, which is 42.5. And notice all you have to do, add the width. And the width was 4. Add the width again, add the width again. So as long as you calculate the first one, the rest are fine. So they are assuming, since they don't have the complete data, everything is close to the midpoint. And so now we're going to multiply 5 by 42.5. That's the meaning of this. Add it to 8 times 46.5. Add it to 8 times 50 times 0.5. Add it to 4 times 54.5. And divided by n. And we have the summation of that already, which is 25, or add them up, it's 25. And when we calculate this, we get 48.26. And take a look. This is how statisticians come up with that, using the frequency distribution table if we didn't have the data. isn't that pretty close to the actual one? And the answer is yes, they are reasonably close.